This is the shit I did in prison. 3-phase motor controller software design. Let's start out with a graph of the logic for a typical BLDC. This represents each phase, whether it's connected positive, negative, or not at all. But when I started, I was like, let's use all the connections, because I'm just thinking 3-phase motors in general. Like big industrial ones that are connected to 3-phase AC. All phases are connected at once. So I'm doing this. And if you know anything about transistors and dead time and whatnot, you got to figure out something for that. So these here look more like a typical setup. I came with the idea of let's use a dead time timer to swap between this and this. Let the sensors take care of the main one. And for example, between 3 and 4 right there, you got negative, positive. You can't instantly make that transition, so you briefly switch to one of these depending on which direction you're going, and then after that very brief dead time, you switch back here and everything's on. Then I had the idea of, apparently I reversed engineered some things that other people have done. I looked into it when I got home and seen some similar stuff. Converting the sensors to a number with 3 binary digits. You can get 0 through 7, but you never get all zeros or all ones, so you don't get 0 or 7. You get 1 through 6 just out of order. I'll use this out of order number to reference an array, and then have that data from that array reference the step. And then they're shifted off by 1 depending on whether you're forward or reverse. I've seen some graphs where people are like, oh, if you just reverse all the polarities, that ain't how it works for reverse. Basically, your sensors trigger the in-between point, more or less, and if you're going forward in time, it's after that line. If you're going in reverse, you go back. That's also why there's 2 of these with the dead time shifted up or down. And here's just a visual representation of that translate array connecting the dots. After sorting all that out, I start thinking, does that change the sensor alignment for my zero crossing points? And I used a lid of a fucking cup to make this shit. Looking into it, realize, oh yeah, the ratio, I'm pretty sure, at least in most cases, some don't, is 3 coils to 1 set of magnetic poles. I say set of magnetic poles because Hulbach arrays exist where it uses 4 magnets. Well, that thing's buried, but like LG direct drive washing machines, they use Hulbach arrays. That was one thing on Edovo that I seen for some magnetic levitation thing. They talked about Hulbach arrays, and I realized, like, oh, my washing machine motor has that. But realizing that ratio, I was like, I don't even need a circle. I can represent it with a couple flat lines, and just make sure that the ratio for the size of electric coils and permanent magnets are the same. Typical zero crossing point would be like right there, the blue. But with my shit, activating everything at the same time, you have 0 crossing points that are more like here, which means you have to put things between the magnets, which is also a thing LG did on their direct drive motors. Isn't the best pseudocode, but basically laid out in 3 pages with throttle logic and sensorless start and reverse, all implemented in software. Again, I don't actually have all the code read out. It's more pseudocode to where an experienced programmer could look at this and be like, oh, fuck yeah. Or fuck, even a really good AI could probably take these pictures and turn it into code. I haven't tried that yet. Anyway,